Volcanic ash in Kansas? It's true, there's thick deposits of this stuff there, but where are the source volcanoes? Geologists began puzzling over this in the late 1800s when these deposits were first recognized. Well, we're coming to you today from the Rock Chemistry Laboratory at the Cascades Volcano Observatory of the U.S. Geological Survey. And it's in places like this that geological mysteries like that of the Kansas ash get solved. Now, initially, it was thought that the ash came from northern New Mexico. That's the direction of the prevailing winds, and of course, there are lots of volcanoes in northern New Mexico. But the chemistry of the ash didn't match the chemistry of the rocks. There wasn't a good match with the rocks in Long Valley Caldera, another big explosive volcanic system located in eastern California. But Yellowstone, spot-on match, not only in terms of the rock chemistry, but also in the timing. These ash beds in Kansas and throughout the Great Plains matched up with the big caldera-forming eruptions from 2.1 million years ago, 1.3 million years ago, and 631,000 years ago. And these deposits have been found throughout the West. In fact, even offshore of Northern California in marine sediment drill cores. And it's not just these most recent 3 eruptions that have deposited ash across the landscape. Past Yellowstone system eruptions have done that as well. The ashfall fossil beds in Nebraska are made up of ash from a 12-million-year-old volcanic eruption when the Yellowstone hotspot was in southern Idaho. We can learn an awful lot about the Yellowstone system by looking at ash that covers the western United States. All right, well, that's the story from Kansas. Now let's head back to Yellowstone and talk about ground deformation, seismicity, and geyser activity that occurred during the month of February.
February continued to see background levels of seismicity in the Yellowstone region. The University of Utah located 125 earthquakes in the area during the month. The largest was a magnitude 2.6 event that occurred on February 23rd, just to the north of Yellowstone Lake. There were also 2 swarms during the month. One included 49 events in the vicinity of Norris Geyser Basin, and the other included 15 events just to the north of West Yellowstone, Montana. Those both occurred in this area where we see a lot of the seismicity in the Yellowstone region between Hebgen Lake and the north central part of Yellowstone National Park. Turning now to ground deformation, this is vertical deformation at the White Lake GPS station on the east side of the caldera. It spans 2 years. Each one of these blue dots is 1 day worth of data. Downward trends indicate subsidence, the ground sinking, and upward trends indicate uplift or rising of the ground. And the trends we're seeing over this 2-year period are the same things we've seen since 2015, that the ground subsides at a few centimeters, an inch or 2 per year, and it's interrupted in the summertime by a little bit of uplift or at least a pause as groundwater is recharged from snowmelt and spring runoff. Now, since about September or so of last year, we've seen about 2.5 centimeters, a little over an inch of subsidence, so we're really just continuing the trends that have been going on now for 9 years. And finally, looking at the tallest geyser in the world, Steamboat Geyser. This is the temperature measured in the runoff channel of the geyser. All of this little spiky activity are minor eruptions, and then we had our first major eruption of the year in the early morning hours of February 26th. And then it dropped back down to background temperatures. So Steamboat remains active, 1 eruption so far in 2024.
Well, that's the YVO update for March 1st, 2024. Don't forget to like and subscribe. And if you have any questions at all, either leave us a comment or drop us a line. Our email address is yvowebteam@usgs.gov. Stay safe, stay healthy, and we will see you next month. Bye-bye. No place like home. 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 No place like home.